When you're doing the fanfare, I'm going to come up. Hello, everyone, and welcome to this very special celebration of the 175th birthday of our state, the 175th birthday of our university. It's a very special occasion. We are here to celebrate not only the great traditions that we have, but to make commitments to a very bright future. Each one of you is going to be part of our state, part of our university for a long time, much longer than I have been. This is my 54th year as a University of Wisconsin-Madison faculty member. I'm very proud of that. That's not a bad fraction of the life of the university, is it? You can do the arithmetic to figure out what this fraction is. Vince, I see you're using your calculator to do that calculation. You don't have to use the calculator, Vince. Just do it in your head. You know, 54 divided by 175, it's more than a quarter of the life of the university. Is it 1/3 of the life of the university? Well, we're getting there, close. What I have used here is a fire extinguisher. In my experiments, we always obey all the safety rules. You notice I have my eye protection on. The fire extinguisher is part of the safety rules. Safety is paramount in everything I do. It should be paramount in everything that you do. Well, we're here to do some experiments. All kinds of experiments. So what does my t-shirt say? Oh, come on, you can do better than that. What does my t-shirt say? Let's have some enthusiasm here in what we do. Hey, we are at the University of Wisconsin-Madison. We're enthusiastic about what we do. We do it always safely, and we obey all the safety rules. That's why I'm also doing what now? What am I doing? That's because I'm going to use a very cold substance. It's called dry ice. Dry ice is solid carbon dioxide. Carbon dioxide, as you know, is a greenhouse gas. You know that. You also know that part of what we exhale every time we take a breath has in it carbon dioxide. It's not the only thing, but it is a very important ingredient. So carbon dioxide in the solid form is called dry ice. It has no smell. I can't smell it. And a solid changes from being a solid to a gas directly without melting. We call that sublimation. Can you say sublimation? Sublimation is happening right now, but we can't see it. How come we can't see it? Because carbon dioxide gas is invisible and it is also odorless. So I want you now to focus your attention on what I have between my two hands right over here. What shape objects do you see? What shape are they? They're cylindrical. How many of them are there? Do I have to ask all the questions? You know, we learn by asking questions. Sometimes we don't get the answer right away. We learn how to be patient. This is how we develop skills to serve us well, not only as individuals, but as groups of people. So there are, how many cylinders are there? And they have in them what? What do you think I have in them? What do you see? Just tell me what you see. Let me help you out a little bit. Do you know the difference between a hint and a clue? A clue is something that you find on your own. A hint is something that someone gives you. Okay, so I'm going to give you a hint. Right? There are 2, 4, 6 cylinders, and they seem to be arranged in some kind of special order. What's the order? The color of what? The color of the cylinders? No, the color of what's inside the cylinders. If you're going to learn, are you ready to learn? If you're going to learn, you have to pay attention. You have to get in the game. So this pair has what color liquids in it? This one. This one. Let me put this here as a background. Does this help to see the colors better? Right? That was not a hint. That was a helpful movement on my part. So what I'm going to do is take the chunks of dry ice and put them in the cylinders in a very special way. So when I get done, you tell me what this special way is. Did I put the dry ice in every cylinder? I put the dry ice in every other cylinder, right? Is there anything happening? What? All I hear is mumble, mumble, mumble. You know, I love that sound. I love hearing mumble, mumble, mumble. You know why? Because we are all free to express ourselves the way we wish. Now, I can ask you a question and get the same answer from all of you. How many cylinders are there? And what is happening inside the cylinders? There's the mumble, mumble, mumble again. This is the freedom that we enjoy in our country. We celebrate freedom, and we celebrate being at UW-Madison. All right, so I don't see exactly what's happening, so I'm going to pull this back. Ooh, I see lots of changes. So in this pair of cylinders here, where I put the dry ice, the color changed from blue to what? And how about in this cylinder? Pink to what? Clear. This is the clear and blue liquid. This is the clear and pink liquid. This is the clear and yellow liquid. This is clear and colorless. Clear and colorless don't mean the same thing. If you learn anything today from me, just remember, clear and colorless. I'm going to tell you a short story. I did this experiment many, many times. And sometimes it has happened to me. I walk on the streets of Madison or at the airport or wherever I happen to be, And someone has always come up to me, and they didn't say, "Hi, Dr. Shakhashiri." You know what they said? Clear and colorless. All right, so you see, oh, look at what, you see anything coming off the top here? What does it look like? It looks like smoke, but it's not smoke. What it is, it's a mist. It is a condensation of the carbon dioxide gas, the moisture on the carbon dioxide gas. You see the bubbles? What kind of bubbles are those? Those are carbon dioxide bubbles, and they're coming from the sublimation of dry ice. But look, I have dry ice right here. I don't see any bubbles. How come? Because in the experiment with the cylinders, with 3 of the 6 cylinders, the solid carbon dioxide is subliming and mixing with a liquid. That's why we see it. And so what's coming off the top here is a fog, and it's a mist. It's condensed water vapor. It's condensing on the carbon dioxide gas that's coming from the sublimation. All right, so now I want to do another experiment here, but I'm missing, wait a minute. I'm missing a dishpan. Can someone bring me a dishpan? Will someone please bring me a dishpan? Please, I'm missing a dishpan. I need it for the experiment. Welcome, Bucky. Well, thank you, Bucky. Bucky is a very good science student. He obeys the safety rules. You see Bucky's goggles? Bucky, welcome once again. I know your parents, your grandparents, your great-grandparents were students in my class, and they did well. How are you doing in my class so far? You're doing well? Very good. I'm happy to hear that. I know you're doing well. I want to make sure you are confident in what you're doing. So this is what we're going to do. You and I are going to do this experiment. You ready? All right. I'm going to take, do you see what I have over here? I have a clear and colorless liquid, and it's what? It's hot. It's boiling. Yeah, and there's water. I'm going to tell you it's water. And the bubbles that we see are water bubbles. They're not air bubbles. The air has been swept out already. So what I'm going to do is take the boiling water, put it in the dishpan like this, and what do you see coming off the top? Steam is invisible. You can't see steam. This is condensed water vapor. That's what it is. Condensed water vapor. So I'm going to put this down, turn this over here, and then I'm going to ask Bucky to take this bucket that's full of dry ice and dump it in the boiling water. Do it, Bucky. That was very well done, Bucky. Very well done. You can. I know it's very exciting. That's why we do it, because it's exciting. But we want to learn from what excites us. So what we have done here, does this look like steam? No. What is it? It's fog. It's condensed water vapor. And you were paying attention. When Bucky first dumped the dry ice pellets into the boiling water, the plume went up, and then it came down. Maybe that has something to do with something we call temperature, and maybe it doesn't. So I want every one of you to always be thinking about what you see, what you hear, including what you hear from me. Think about it and try to make some sense out of it. So Bucky, this was a very, very cool experiment. I know that you are very busy. We're getting close to graduation. Are you going to graduate? How many years? You're not going to graduate? How many years is going to take you to graduate? 10 years? No, 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 no. Bucky, the people who take my course have graduated most of the time in 4 years. In 4 years. That's what everyone should aim to do, is to finish in 4 years. Some people are doing it faster now. All right. So, Bucky, I know you're busy, but it's a weekend. I would like you to stay. Would you like Bucky to stay? Well, Bucky, I have a seat reserved for you right over there. So if you just walk there gently. Thank you, Bucky, for joining me and for helping with doing this experiment. So, okay, watch your step, Bucky. Yeah. All right. I want to try to get organized for what I have planned for you here. I'm not quite sure what this. Oh, I found what I'm looking for. What does this look like? What color is it? And I will tell you, because you're not up close to it. It's a corrugated tube, and it has an opening here, has an opening here, and I can blow air through it. That's not very interesting, but maybe if I do this to it. So we start thinking about this corrugated tube and how moving air generates a vibration, a sound that hits our eardrum, and we hear that. So for my next experiment, this is a pleasant interruption. I like interruptions. But really, for my next experiment, what I want to do. All right, you've made your point. All right, you've made your point. You are talented musicians, and you also work in my lab. So what is it that you're interrupting me for?
That's my experiment.
That's your experiment? You're going to do this experiment?
Yeah.
Okay. Well, so Hannah, which one is your experiment? This one?
Yeah.
And Josh, which one is your experiment?
That one right there.
So this is the experiment I've been trying to do here. So we have clear, 2 colored liquids. One is what? No color, right? So I'm going to do, and Hannah and Josh also are going to help me do this. But let me do mine first. I'm going to take a clear and colored liquid from this vessel right here, and I'm going to add it, and so we'll see what happens. If you know what you're doing in science, you can not only appreciate color, but you can generate color. So Hannah, what do you got over there?
I have some dimethylglyoxime.
A what?
Dimethylglyoxime.
Dimethylglyoxime. That's a mouthful. What are you going to do with it?
I'm gonna pour it in. Let's see.
Very, very good. Thank you, Hannah.
Yeah.
And Josh?
We have some lead nitrate here.
Lead nitrate into a clear and colorless liquid. So the lead nitrate was mixed with a clear and colorless liquid that had in it potassium iodide, and this yellow substance, which does not dissolve, is called lead iodide. So lead is relevant not only to our state. We're called the Badger State. You know why we're called the Badger State? Some of you are nodding your head, saying yes. Bucky knows why we're called the Badger State. You know what? Have you visited my website? Raise your hand if you visited my website. Okay, what website? You should go to my website, scifun.org. Just Google Science is Fun. Go to scifun.org, and then you'll find all kinds of information about lead and how insidious lead is, and about the history and why we're called the Badger State. You can find all kinds of experiments. You can download experiments you can do at home. not ones with lead. We don't have safe experiments posted on the website. So I invite you to go to scifund.org. Can you say scifund.org quietly? Just say it quietly a couple of times. scifund.org. scifund.org. This is how we memorize things. But what good is it to memorize something if we don't use it? So go use it. So I know Hannah and Josh and the other talented musicians, you're going to go back to your seats now. And I'd like to invite you to really showcase the talents that we have in the arts on our campus. And so there you have it, ladies and gentlemen, the Science is Fun Quintet. Give them another hand, please. You know, we celebrate science, the arts, and the humanities. What is science? This is a rhetorical question I would like you to think about. What are the arts? What are the humanities? Why do we celebrate them together? Science, to me, is a way of looking at the world, of understanding the natural beauty of the complex world that we live in. The arts, they enrich us. So do the humanities. They're soothing. What they played was very, very soothing. The humanities give meaning to what we do. That's what makes us a university. We are the University of Wisconsin-Madison. We are not the Wisconsin Institute of Technology. We want to celebrate the complexity of what we do all together in the classroom and outside the classroom. And I want to take a moment to tell you about something that I am personally celebrating. Next month will be the 50th anniversary of my being sworn in as a United States citizen. It was a momentous occasion in my life. The difference between what happened before I was sworn in and after I was sworn in is that I became eligible to vote. And I ask everyone in the audience to vote in every election. In every election. If you are, as many of you are, under 18 years old, you cannot vote yet. I have a special request of you. I want everyone who's under 18 to talk to someone or more than one person over 18 and ask them if they're going to vote. And if they say no, you say to them, why aren't you going to vote? We live in the most advanced society in history. Advances in science and technology have greatly helped us, but we need to participate as responsible citizens in the country that we all belong to. So please vote in every election from here on. And that's what, you don't owe me any favors of any sort, but that's a big favor you can do me if you vote in every election. So please do it. I want to also tell you when I was sworn in, I with other people, Judge Doyle, the father of our former governor, he said to us many things. But the one thing that he said that I remember, and I quote him all the time, he said, enjoy your freedoms. Enjoy your freedoms. That's what I say to you. The freedom of inquiry, the freedom of expression, the freedom of religion, all the freedoms that we have. And let's do everything that we do in the most responsible ways that we know how. Let's be respectful of each other when we talk with each other, even when we differ with each other. But let's always act with confidence, with trust, and with respect. So that's the special celebration message that I have for you on the occasion of my becoming a United States citizen. All right, now I'm going to do an experiment. What do you see I have in my hand here? Okay, so what do people usually do with balloons? You know, one good way to sharpen your powers of observation is to report your observations. So, you know, I said, what do you see I'm holding in my hand? And you said balloon. But if someone is listening to you on the radio, I can't see what you're saying, what you're seeing. What do you say to them? You say, what do you see? What color is it? Hey, do I have to ask all the questions all the time? We always learn from what we ask. So ask questions. Don't be afraid to ask questions. Okay, here's the balloon. If I let it go, it drops down to the tabletop. It bounces, but I need it up here. Do you suppose there's a way for me or you to hold this balloon up in the air without touching it? Yes or no? Why? Some of you are saying yes because you know how it's done. Some of you are saying yes because you have confidence in me. Otherwise, I would not ask you that question, right? So here's how I'm going to try to do it. Here we go. But my neck is getting tired. So maybe I should use something else. How about if I use this? What is this? A blue hairdryer. Very good. Very good. Very good. Report your observations because when you hear them, others hear them and you can validate them. So here's this. Okay, am I touching the balloon? Is it suspended up in the air? What's holding the balloon up in the air? Air. There's air right now. There's air right now. What's coming out of the nozzle? Moving air. The air is moving. So here's what I'm going to do. I'm going to try to take Too strong. Too weak. That's how we do experiments. We keep trying. We're patient. Can you do this at home? Try doing it this way. Tilt it a little bit to the side. Tilt it all the way to the side, then everything falls off. So it's moving air. You know what? You can have that as a souvenir. You can have, thank you for doing that. So what I'm going to do next is I'm going to take a what do I have here? I need a volunteer from there. Is that everybody? But let me tell you what I need you to volunteer for. So I'm going to come aside over here and step down here. How about you? All right. What's your name? Laura. Okay, Laura, go over there. You hold this. So hold it up so everybody can see what we have. What do we have? I have an opening over here. Do you have an opening over there? Yours is closed? Okay, so let me show you what I'm going to do. I'm going to try to blow air into this 6-foot red tube and see what happens. Maybe Laura can help me do that better. Okay. So I did a little bit here. So I'm going to let the air out. So okay, Laura, you try to blow air into the way I did it. Okay, go ahead. 1 more, 2, 3, 4. She's hyperventilating. That's enough. That's enough. Let's see what she did with how many breaths? 4. That's not too bad. Not too bad. How are you feeling? You're tired already? All right, so I'm going to let this out. I'm going to show Laura and show you how you can fill this with 1 breath. You don't believe me, do you? Oh, you believe me because you've seen it. You've done it before. You know, we like doing experiments over and over again. So Laura, hold it up so everybody can see it. Okay, the opening is over here. So what did Laura and I do to begin with? We blew air into it like we blow into a paper bag. But watch what I'm going to do. I'm going to open this up like this, and I'm going to blow 1 long breath right down the middle. Let go. So, Laura, do you think I have that much air in my lungs? No one has that much air in their lungs. What we were doing here is taking advantage of the fact that a stream of moving air, like we did with the hairdryer, sucks in other air from the sides and inflates it. So Laura, I think what you have done is very helpful. I appreciate it. And you need more practice, so that's for you. Give Laura a hand. All right. So at this time, what I'd like to do is invite the provost of the University of Wisconsin-Madison, newly arrived. He's been here less than a year, but he's been fantastic so far, and he's going to keep it up. I'd like to invite Provost Charles Isbell. Thank you. Welcome.
Thank you.
How is life in Madison so far?
It is fine. I've learned about winter.
Where did you come from?
I came from Atlanta where it's 72 degrees today.
We'll get there.
Yeah, we'll get there.
We have 4 seasons here. We enjoyed the changes. Well, maybe this season has not lasted long enough yet. But so I'm very glad that you're here. I'm very glad that your leadership is being bold. We need fresh blood. And are there things that you're interested in?
Yes, there's some, but first, wait. Hi, everybody. Hi, thank you. Here's the thing I would like to do, if you can help me.
Sure.
The year before you became a professor, I was born. And and when I was born, my mother gave me, a little baby, a tree. And every year on my birthday, she brings this tree out. It's about this big. And what I'd like to do is I'd like to give her an ornament.
An ornament.
An ornament, maybe a big metal ornament to go on that tree.
Oh, a
for my next
metallic
birth-
ornament?
Yes, for my next birthday.
Let me look around here. I see we have glass. We can make, these are the shape of an ornament, right?
Yeah.
Yeah, but let's see what we can do. So what I need is, there it is right here. If you would please put your goggles on and put your gloves on, because these round bottom glass containers have in them hot water.
Okay.
So you got your goggles on?
I do.
Otherwise, you can't do the experiment. All right, so I'm gonna bring this, they fit?
Maybe. Here you go.
Okay. I'm gonna take this vessel, you take the other one, but we're gonna empty it in here, just let's glug, glug, glug.
Okay.
All the way, we emptied that all the way. All right, very good. We put them back. We take this out of the way. And you have two small flasks, and I do too. So the first thing we're gonna do is take what's in the bigger flask, take the rubber stopper off, and pour it in a clear, colorless liquid. And we put the stopper back on. Then we take the second one, another clear and colorless liquid, and we add this one. And then we put the big rubber stopper on, tighten it,
Okay.
and start mixing the liquids together, like this, swirl it like this. Oh boy, I see some changes. Do you see any changes? What do you see? I'm beginning to see myself in here.
Wow.
It's a metallic ornament. That's what the provost requested as a gift to his mom. How is that? How is you doing?
Pretty good.
Pretty good? So this is the deposition of a thin layer of metallic silver inside this round bottom flask. And this is how we make ornaments for the holiday season in my lab. So if you go around town and see big ornaments like this, you know where they were made. And this one is especially for you. We're going to deliver it to your office so you can then give it to your mom.
Thank you.
Thank you. Thank you very much, Charles. Thanks. What I really would enjoy now is another interlude from our musicians. So please welcome them one more time, please. Thank you very, very much. I said something about carbon dioxide before. I want to come back to it for a moment because we all know, and if you don't, we should know, and you're going to know right now that carbon dioxide gas is a greenhouse gas. Greenhouse gases are good for our planet, but too much of anything is not good. And since the Industrial Revolution, humanity has greatly increased the amount of carbon dioxide that's in the atmosphere because we rely too much on fossil fuels. And we should mitigate the increase in carbon dioxide into the atmosphere. So carbon dioxide is one of 4 main greenhouse gases. Another one, who can name me another one? Just say it out. Don't raise your hands. Just say it out loud. The 4 main greenhouse gases are carbon dioxide, nitrous oxide, methane, and the 4th one is the one that's present in the biggest amount, water vapor. We can't do anything about water vapor. It's part of the water cycle. But the increase in carbon dioxide in the atmosphere is warming up the planet. Global warming is real. And we individually can take and collectively can take important steps to deal with using less fossil fuels, get alternative sources of energy for what we do. So here's my experiment. I'm going to take, what does this look like? A baby bottle. And I have replaced the nipple that has the hole in it with the rubber bulb from a medicine dropper. I'm going to show you how strong this piece of rubber is. I'm going to try to inflate it with all the powers of my lung. Here we go. Cannot do it. This is a very strong piece of rubber. What I'm going to do is use a carbonated beverage. It's called carbonated beverage because it has in it, among other things, what? Carbon dioxide, right? So listen to this very familiar sound. So I'm going to take the baby bottle, fill it up with this carbonated beverage. What do you see? You see bubbles. What kind of bubbles are those? Carbon dioxide bubbles. Why are they? They're coming out of the liquid because they're not under pressure anymore. So I'm going to put the screw cap on like this, and I'm going to tighten it. What should I do next? Oh, you've done this experiment before? I'm going to shake it. And there you see how much carbon dioxide is in there. The pressure is so high, it can inflate the strong piece of rubber that neither I nor you or any other human being can inflate with all the powers of their lungs. So we need to learn about chemicals. We need to learn about the science of global warming, and we need to take responsible action by voting for the right people, by voting for ways to help protect our planet. So I open it up. Oh, I made a mess here. I know you want me to make a mess. Yeah, yeah. This is a non-sugary carbonated beverage, so my hands are not sticky. So now what I would like to do is demonstrate what we do at the University of Wisconsin-Madison. What are the ingredients of success at UW-Madison? First, we have structures. This is, I want everybody to look at this. This is a 4-liter beaker. That's the volume of it. If you look at it right now, you just learned how big 4 liters is. And you cannot unlearn it. You may forget it. Those are 2 different things. This is 4 liters occupying space. So we have buildings that occupy space. I'm going to take a small magnet coated with Teflon, put it in. I'm going to turn the light on so you can see this better. I'm going to turn the switch on, and now the magnetic bar is spinning. And I'm going to tell you the magnetic bar is spinning. As I look down at it, it's spinning in this direction. What direction is that? Is that clockwise or counterclockwise? You can't tell me because you have a digital watch? Is that what you just said? This is turning clockwise as I look down at it. Now, what I want everyone to do is to visualize, because in science, we visualize a lot of things. I want you to look at this bar, not from above, but from below. So suppose there's a ceiling fan up there moving in this direction. As you look up at it, what direction do you see? Clockwise or counterclockwise? You're confusing me. If I look down at it, it's moving in a clockwise direction. When I look up at it, it's moving in a counterclockwise direction. So the vantage point that we have is important. And we have to pay attention to where and how we make the observation. So the ingredients of success. The first one is the fact that we have an outstanding faculty and staff. And all they do is fill up space. And then we get very talented students. And they fill up more space. But then we need another ingredient. This is the ingredient where we have the support from the state, the support from all of our donors, and we mix all these three together. I don't see anything happening. How come I don't see anything happening? I'm not looking? Yes, I'm looking at you. What do you mean I'm not looking? I'm looking. What are you looking at? Oh, you're looking over there? You look, the last time I looked, the color in the liquid was yellow. You tell me when to look. Shall I look right now? Yes or no? Yes? Yes? Shall I look now? I don't want to trip over anything here. Right now? Shall I look now? Are you sure? Right now? Every time I look, it's yellow. Look at that. You tell me when to look. Come on. Right now? You sure? Every time I look at the liquid in the beaker, it's yellow. Maybe you can help me better on this side. Tell me when to look, okay? Shall I look right now?
No,
No, don't look there. Right now, you're sure? Are you sure? I don't want to trip over anything here. What is happening here? What? Look at it. It's yellow again. Okay, so I told you I'm looking all the time. But I wasn't looking over here. Remember? Do you remember what I said at the beginning? Pay attention. Pay attention to what's going on, because you don't want to miss out on beautiful transformations that happen. The beautiful transformations that happen to everyone on campus here. Everyone undergoes transformations. The administrators, the faculty, the staff, the students. That's what the university is all about. That is why UW-Madison is one of the greatest universities in the world. It's not because I say so. It's because you and others make it so. So this is an example of what is called a chemical oscillating reaction. And but colors oscillate. That's why it's called an oscillating reaction. And this reaction is one of about 50 known such reactions. But this one is very special to me. It's special to me for two reasons. One, it was discovered by two high school teachers. And they published a paper 50 years ago in the Journal of Chemical Education describing this beautiful, captivating behavior that we look at. And the second reason it's special to me is that it illustrates the beauty of paying attention, asking questions, learning about the names and the properties of different chemicals that are in there. I don't know if you can see when the color is yellow, there's some gas bubbles. Those gas bubbles are carbon dioxide bubbles. So this reaction, among other things, produces some carbon dioxide. But I'm going to tell you, the overall reaction is the decomposition of hydrogen peroxide. Hydrogen peroxide is what we get in the drugstore, 3% hydrogen peroxide. This is 30% hydrogen peroxide. So you can't do this experiment at home. It's not a safe experiment to do at home, but it's a beautiful demonstration, illustration of the complex chemical world that we live in and how we can all, musicians, nurses, artists, everyone in society can learn from science, enjoy the arts, and give meaning to our lives. And I close by thanking you for joining us in this great celebration today. Thank you all very much. The what? Oh, there are about 24 different things.